Topic 2.8 Fluid Dynamics. Under this topic, what we are going to learn is about a principle which we can use to describe, study, and predict about conditions and situations of flowing fluid, that is liquid or a gas, flowing liquid or a gas. Here, in respect to fluid dynamics, we are going to learn very important principle, which has been developed based on mechanical energy conservation. That law is called Bernoulli's principle. That principle is called Bernoulli's principle or the Bernoulli's equation. That is what we are going to mainly focus on this topic. However, before talking about Bernoulli's principle, there are a few scientific terms we should define so that we can use them meaningfully in explanation of Bernoulli's principle. Therefore, let's see first of all what is called a steady flow. Really, steady flow is in respect to a fluid flow. If we in the space through which the fluid flows, if we concentrate on a specific point on the space of fluid flow, we keep on examining that place, we will be able to notice that fluid particles keep on passing through that point. Each and every fluid particle passed through that specific point have the same velocity, that is both magnitude and direction of the speed is the same if the flow is steady. Such a flow is called a steady flow. So please note down subtopic steady flow. Under that, write down if the flow of a fluid is steady, then all the fluid particles that pass any given point within the fluid flow have the same velocity. Okay, now listen. There is another term. The next term we are going to look at is turbulent flow. What is a turbulent flow? Turbulent flow is really the contrary of the previous. It is contrary of the steady flow. That is the when we are observing a point within the space of fluid flow, if the fluid particles passing through that specific point, if they do not have, if each and every fluid particle passing through that point does not have same velocity, such a flow is called a turbulent flow. Please write down subtopic turbulent flow. Under that, write down in a turbulent flow, the velocity of the fluid particles passing any given point within the fluid flow, passing any given point within the fluid flow, vary with time, vary with time. Okay, now listen. Next thing we are going to learn is what is called line of flow. Line of flow. Really, a line of flow. What we call line of flow is, now when there is a fluid flow, if we select a specific fluid particle and keep on observing the same fluid particle throughout, that path traced by a single fluid particle is called the line of flow. Please write down subtopic line of flow. Under that, write down line of flow is the path. Line of flow is the path followed by a fluid particle. Now we can demonstrate the line of flow in this way. Now look at here. If we can set up water flow through a transparent tube within the laboratory, and we can attach a colored dye with the container like this, where we can control the addition of dye. And if we add a single drop of dye for a steady flow of water, then stop the dye flow, then we will be able to see that a small dot of dye flowing through the water, and that path traced by that dot of dye is called the line of flow. Okay, now we will move on to the next term. Next term we have to study is streamline. Streamline. Streamline is really, we can demonstrate the streamline using the same setup. If we keep on adding drops of dyes without stopping adding after single drop of dye, we keep on adding drops of dye with shorter time intervals. Then all of that drops of dye will start flowing along that line of flow. When a line of flow is full of flowing drops of dye, that line of dye will represent a streamline. That is a streamline. So streamline is a set of fluid particles flowing along the same line of flow. Please write down subtopic streamline. Under that, Please note down. A streamline is a curve made by fluid particles flowing along a line of flow. A tangent to this curve, at any point represent the direction of velocity, of the fluid particles at that point. Next paragraph. Streamlines never cross each other. Next paragraph. In a steady flow, the streamlines coincide with lines of flow. Okay, now listen. So a streamline will be represented if we keep on releasing drops of dye continuously. Then that line of drops of dyes will represent a streamline.